So going through a simplified example to illustrate how carbon taxes or pollution taxes and cap and trade systems may be similar, we could look at this example here in Granville. So if we were to look at this table or this graph here, we're showing the same thing. We're showing this downward sloping marginal abatement cost curve that if you release a lot, there's not much cost to reduce it by 1 unit of gunk, but the more you reduce, the higher that cost becomes. And here we could see that this factory is pretty much costless to reduce. So we can have a situation where they're actually producing 20, but those first 10 units, as could be seen in this example here, are pretty much costless to reduce. So if we wanted to go from a situation that they were both producing 20 and we wanted to drop it down to, let's say, 25 total, well, we have a situation where one of them is much cheaper to reduce it, because for this individual over here, the plant B, we have a situation where they can reduce the first 10 units at no cost. So this unit here could be reduced. So I have 1, I have 2, I have 3, 4, 5, 6, and so on. And you could wonder, well, how could a firm reduce emissions from a costless standpoint? Well, sometimes as these policies come into place, some businesses realize that it might actually be cheaper to operate in a more environmentally friendly way. If you introduce more LED light bulbs in a building, your bill may go down, that even though there was a certain cost associated to putting those LED light bulbs in place, your final bill might be smaller or exactly the same, even though you're accounting for the extra costs associated to that LED light bulb. Same thing goes for retrofitting windows. And if you think about pollution in terms of packaging and plastics, well, maybe the alternative is actually cheaper, or maybe something else kind of happens that makes it that it's not more expensive, that you just kind of remove this packaging and you're still okay. So it is possible to have costless pollution. And if we wanted to keep on reducing pollution, well, the lowest cost here would be $1, and then 2, and so on. So we could see that if we wanted to reduce the level of pollution by 15 units, what makes the most sense is, instead of having each of them, or like 16 units, have each of them reduce 8 units each. It doesn't make sense for this firm here to be able to keep on reducing more at a costless manner, but to say to this firm here that its last unit that it reduced cost $8 to reduce it. It's not the most cost efficient way of doing things. Ideally, when you're trying to reduce, you're trying to make everything as cheap as possible to society, which means that whoever can reduce it most cheaply is the one that should be doing it. If we think from a situation where both of them had a certain level of permits of pollution, well, you could expect that Plant B could sell permits to Plant A to reduce its pollution less. And therefore, Plant B just reduces its pollution more because it's cheaper for them to do so. If I go back graphically here, it's this whole idea that if I want to reduce the total amount of gunk to 20 units, well, it makes most sense for us to have this kind of situation where this plant still produces 13 units of gunk and this one only produces 7 units of gunk, compared to a situation where they would be both producing 10 units, because here we would have pretty much no cost, and over here we would have a very large cost associated to that. If we want to reduce gunk further, well, we want to make sure that the cost, the marginal cost of reduction of that last unit, is the same. So the thing is, when we assume that we want to reduce a certain quantity, so when we use a cap and trade system, we know the quantity, but the price that it's going to become is undetermined. Whereas if I use a tax system, I know the price, but the quantity is not sure. So let's say right now I say, well, what would happen if I had a price of $10.50? So this is my price. Well, I could expect Plant A to reduce all of these units here, because it's more expensive to produce them. It's less expensive to reduce them than to actually pay this fee. And for this firm, the same kind of thing, all of these units here would be removed. And if we go back to the table, we could see which units would be removed. I would definitely stop producing this unit of pollution if it only cost me $1 to do so. But if I don't, I pay $10.50 and charges. So I would reduce all of these units, and even the one that's $10 to reduce its emissions, because I'd rather not pay that $10.50 tax. But I would stop here. These units would still get produced because the cost of reducing it is greater than the tax associated to it. And for this firm here, I would stop over here. So afterwards, you could kind of evaluate how many units would actually be released in this situation. Well, we would have all of these units plus all of these units would be my total quantity that would be released or polluted. So regardless of which way you go about doing things, they both can achieve a similar outcome. Like I said, it's that clarity of knowing what's the quantity or what's the price that determines whether you prefer one metric or one tool or the other.